Okay, now it is the 12th question. Which among the following is the only possible plunge for a lineation located in the foliation plane striking 20° and dipping 40° southeasterly? So this is a structural question, that is a plunge for lineation, that is plunge is always for lineation, then on a foliation plane, it is on a foliation plane and it is striking 20° north and dipping 40° southeast. So from this will be that, as we know, plunge is a linear feature, so we need to apply some equations. So now we can draw the foliation plane here. How to draw the foliation plane? With known data, we'll be drawing the foliation plane. Yes, and we'll be marking the north. Here it is the north, east, then it will be the west, and here will be the south. So now we have marked east, west, north, south. Then it is given that foliation plane, the strike, that is 20° north. A strike is given 20° north, so we can draw a strike here. It is 20°. Okay. Yeah, slight difference is here. Here it will be like this. Okay, this is actually 20°. This is 20° north. Okay, 20° north. Now we need to draw the foliation plane. So if I draw something roughly, in the sense, we may draw something like this. And we can draw something like a foliation plane will be here. So this will be the foliation plane direction, and here this will be the strike, that is 20°. Here this will be the 20°, and this is 20° north. Then always the dip will be perpendicular. It will be perpendicular to the strike. So this will be the foliation. The dip will be like this. Dip will be like this. Okay, that is plunge of lineation. That is the plunge of lineation. We need to calculate this plunge of lineation. Okay, from this we'll be calculating the plunge of lineation. So how we'll get? You will get the true plunge in the perpendicular to the direction of the strike. So what will be this? This will be the true plunge of this, and it will be perpendicular to this strike. This may be the strike, so it will be perpendicular to the strike. So what can we do? So here this will be the 40. Here you can see this 40 will be coming, that is a dipping degree. So this will be the strike. So it will be perpendicular to the strike, that is it will be in the southeast region. It is a southeast region having 20°. Why? Because when we consider it as complete 90°, we will be getting that. Okay, from this 20 to this 20°, when we calculate this angle, we will be getting this as 20° southeast. So now we have got the answer 20° southeast, because it falls in between this region. So what will be the possible answer for our question? Which among the following is the only possible plunge for the lineation located on the foliation plane of strike 20°? Yes, dipping 40°. Yes, it is the 40° here. So what will be the answer? It is the only possibility is to have 20° southeast, not 20° northwest, not it is 45°, and not this one. It will only possibly falls in this region. Okay. Yes, now the next question. Which one of the following tectonic plates has the maximum average velocity? Yes, it is very important question, that we need to know the maximum average velocity of various plates. So all these plates are moving with different velocities. Now you can come back to this diagram. Yes, in this diagram you can see various plates: Eurasian plate, North American plate, Caribbean plate, South African, everything is here. And you can see all the plates here are moving with various velocities. Everyone is moving with various velocities. So we need to find which one is having the maximum velocity among this four. That is Eurasian, Pacific, American, North American. So we need to find which among this will have the maximum average velocity. So to answer this question, look at the given figure. Yes, as we know, various plates are moving with various velocities. Now look at the Pacific plate. Here you can see the Pacific plate, which is the largest among. So now you see Pacific plate, which is largest, is moving with a velocity vector that is larger in size when compared to these other plates. So here you see Pacific plate, it is moving 161, 110. That is the NASA plate. NASA plate is moving with the maximum 106. When we compare the other values, it is 87, 95, 78, 66, 65. Antarctican plate is 60, 88, then 40, 37. So in this diagram, you can find the maximum value ranges is for the Pacific plate. Pacific plate is having 180, 161, 110, and among that, one biggest is NASA plate. NASA plate is the largest. So Pacific is the right answer for this question. That is, which is having the maximum average velocity. So the maximum average velocity is for having the Pacific plate. Okay. Now, next question. A limestone contains lime mud around 25%. Lime mud and locums which are separated from each other. The name of the rock as per Dunham's classification. Dunham classification is very important in sedimentary. Here we need to find 25%. Lime mud is having 25% of allocums. Yes, for your better knowledge, I have added the Dunham's classification here. That is, allochthonous limestone original components are not organically bound during decomposition and also during decomposition. Okay, organically and not organically. Now come back to the very first session. You can see contains lime mud, that is less than 0.02 mm. Then here it is no lime mud. We need to know the lime mud percentage is 25%. If it is greater than 25%, what will be the type of rock formed? Options: mudstone, wacky stone, pack stone, grainstone. Here you can see the various names of the rocks formed. Various rocks formed and also various composition. Now the criteria: lime mud, it is containing 25%. So here the mud support is given. So if it is less than 10%, then it will be mudstone. So here it is 25, so it is not the answer. Greater than 10%, it is wacky stone. Yes. So the lime mud is greater than 10%, that is 25%. Then the rock is wacky stone. So the answer among this is wacky stone. If it is mudstone, in the sense mudstone will have less than 10%. It is less than 10%. Then if it is pack stone, means it is grain supported. It is not mud supported, it is grain supported. No lime mud is present for pack stone and grain stone. For pack stone and grain stone, there is no mud supported, it is completely grain supported. So for pack stone and grain stone. For mudstone, it is less than 10%. That is, lime mud is less than 10%. So the appropriate answer is wacky stone. Okay.